Hi, welcome all of you to another episode of swapnangal. If you haven't subscribed my channel yet, please subscribe and support me. In this video, we're going to talk about the sun. In the prehistoric times, the sun was a religious symbol and sometimes was described as a powerful god. They said that the sun, the moon, and all other planets orbited the earth. Nicholas Copernicus came up with the theory that all the planets in the solar system orbited the sun, but failed to convince the people. Galileo Galilei demonstrated to the people that all the planets in the solar system orbited the sun, and he was prosecuted for the truth that he said and was kept under house arrest until his death in 1642. Our sun is a yellow dwarf star. It has a diameter of approximately 1.39 million kilometers and was born about 4.6 billion years ago. Our solar system is part of Orion Arm in the Milky Way galaxy. Our sun contains about 99.86% of all the mass in the solar system, making it the most massive object in the solar system. The photospheric composition of the sun by mass is as follows: hydrogen 73.46, helium 24.85%, oxygen 0.77%, carbon 0.29%, iron 0.16%, neon 0.12%, nitrogen 0.09%, silicon 0.07%, magnesium 0.05%, and sulphur 0.04%. It is rotating counterclockwise when we are looking from high above the solar system's north pole. The sun has different rotational speeds. At the equator, the sun spins once about every 25 days. But at its poles, it takes 35 days. It has many different layers. The sun's inner layers are the core, the radiative zone, and the convection zone. The core is the most center point of the sun and the hottest part of the sun and the solar system, where fusion takes place. It has a temperature of approximately 15 million Kelvin. The radiative zone, a zone between the core and the convection zone. In this zone, the energy created by the nuclear fusion in the core is conveyed by the photons to the convection zone. The temperature drops to 1.5 million Kelvin in the region. The convection zone is the outermost inner layer of the sun. Energy is transported by convection to the photosphere. It has a temperature of about 5700 Kelvin. The sun's outer layers are the photosphere, the chromosphere, the transition region, and the corona. The photosphere is the innermost outer layer where light is radiated and with temperatures about 6000 kelvins. The chromosphere, the layer on top of the photosphere, is where hydrogen emits light with temperatures from 4500 to 20,000 Kelvin. The transition region is a region where the ions emit light in the ultraviolet region with temperatures varying from 20,000 to 2 million Kelvin. The sun's corona is the outer part of the sun's atmosphere. The temperature is approximately 5780 Kelvin. These are the activities that are happening in the corona as we know. coronal mass ejection is a giant cloud of solar plasma drenched with magnetic field lines that is blown away from the sun, often during strong, long duration of solar flares and filament eruptions. The solar wind is a stream of charged particles released from the upper atmosphere of the sun, called the corona. Both the fast and slow solar wind can be interrupted by large, fast-moving bursts of plasma called coronal mass ejection. A solar flare is a sudden flash of increased brightness on the sun, usually observed near its surface and in close proximity to a sunspot group. Sunspots are temporary phenomena on the sun's photosphere that appear as spots darker than the surrounding areas. The number of sunspots varies, and it has a cycle too, and is called as solar cycle, which has a period of about 11 years. The corona is usually hidden by the bright light of the sun's surface. This makes it difficult to see without using special instruments. However, the corona can be viewed during a total solar eclipse. As all of us know, a solar eclipse is happening when the moon and the sun lines up as seen from our point of view from Earth. The distance between the sun and the Earth is considered as one astronomical unit, or 1 AU, which is 149,598,000 kilometers. The heliosphere is a thin atmosphere of the sun that extends out past the orbit of Pluto. Are we living inside the star or not? We use the following missions to study about our sun. Pioneer 5 was launched by NASA on 11th March 1960. Its primary mission was to measure the magnetic field phenomena, solar flare particles, and ionization in the interplanetary region. Pioneer 6 was launched on December 16, 1965. Pioneer 7 launched on August 17, 1966. Pioneer 8 launched on December 13, 1967. Pioneer 9 launched on November 8, 1968. These 4 spacecrafts are launched by NASA, and its missions was to observe the network of solar orbiting, space weather monitors, observing solar wind, cosmic rays and magnetic fields. Helios A launched on November 1974 and Helios B launched on December 10, 1974 was launched by NASA and the German Aerospace Center to observe the solar wind, magnetic and electric fields, cosmic rays and cosmic dust between Earth and Sun. The ISEE-3, launched on 12th August 1978 by NASA, was sent to study the solar phenomena in conjunction with Earth. Launched by NASA and the European Space Agency on 6 October 1990, Ulysses was sent to study about the Sun's poles. A spacecraft by NASA, WIND, began its mission on November 1994 to study about the solar wind measurements. ACE-0HO was launched on May 1996 by NASA, and the European Space Agency was sent to investigate of Sun's core, corona, and solar wind and comet discoveries. Launched by NASA on August 1997, ACE was launched to study in depth of the solar wind. Genesis spacecraft that gathered solar wind samples was launched by NASA on 8 August 2001. Stereo A launched on October 2006 and Stereo B launched on December 2006 by NASA to gather images of the coronal mass ejection and other solar phenomena. Launched by NOAA, an American scientist agency, on February 2015, DSCOVR was launched to monitor the solar wind and mass ejection. Launched on 12 August 2018 by NASA, the Parker Solar Probe was sent to make a close solar corona study. European Space Agency launched the Solar Orbiter on 10 February 2020, and its primary mission was to explore the solar and heliospheric physics. The Indian Space Research Organization has scheduled to launch a satellite named Aditya at the end of 2020 to study about the solar corona. The length of a star's life depends on its size. Yellow dwarf stars can live up to 10 billion years, and at the age of 4.6 billion years old, our middle-aged sun is halfway through its lifetime. All stars die, and eventually, in about 5 billion years, our sun will too. Once its supply of hydrogen is exhausted, the final dramatic stages of its life will unfold. As our host star expands to become a red giant, and then tears its body into pieces to condense into a white dwarf. Don't worry, it'll take for a long time. Thanks for watching my video. Please share and like my channel. Catch you in the next video. Till then, signing off, Shoni.